Hello, folks. This is selected solutions to the lesson 1.3 practice worksheet. So I've already got all the answers filled in here, but I'll just kind of explain a few of them for you. So Bohr diagram, of course, has the element symbol in the center, and we have the number of electrons in that atom placed in the rings. And of course, we can have up to 2 electrons in our first ring, up to 8 in the second, and up to 8 in the third. And to figure out how many electrons we have, let's do magnesium. Magnesium is element number 12, so it has 12 electrons. And so we put 2 in the first, 8 in the second, and 2 left that have to get placed in the third ring. And Bohr-Rutherford is almost the same. There's just a little bit more detail in there. So argon, let's do argon. It's element number 18. So it must have 18 protons and 18 electrons. And to figure out the number of neutrons, we check the mass of argon and round it to a whole number. So that would be 38. And 38, take away the 18 protons, leaves 20 neutrons in the nucleus. And so we have to indicate 18 protons, 20 neutrons, and then to fill the electron rings with 18 electrons, 2 in the first, 8 in the second, and 8 in the third. So the third is full, which makes sense because argon's a noble gas. It's at the end of the table, so its outer electron ring is full. Figuring out the valence electrons, we just want to look at the group number in the periodic table and the number that it ends with. So neon is group 18. So we would ignore the 1, and then the 8 indicates the valence shell has 8. Some multiple choice here. I'll skip over that. So trends are pretty easy to determine here based on the data given to you. So down a group, the radius increases, and that's because, of course, we're adding a new electron ring every time we go down to the next row. So it's definitely going to get a bigger radius. Explaining trends. So there's always, as you saw in the lesson video, there's always 2 ways to explain trends, and that's going up and down a column and going left and right across a period. And so the factors there are adding more electron rings, which contributes to electron shielding, and then moving left and right on a period is increasing the number of protons in the nucleus for the exact same electron ring, which increases the effective nuclear charge. So we can explain the trends that we see in the table using those 2 factors. So for atomic radius, we can apply those 2 concepts to explain that trend. And going across a period, of course, we have a greater pull on the electrons as we go to the right. So that's going to make the radius smaller because of the increasing effective nuclear charge. Okay, so that takes care of 8. Why does it need energy to remove an electron? Well, because the electrons are being held or attracted to the nucleus due to the protons. So we have to overcome that attraction. It's kind of like removing or pulling apart 2 opposite charged magnets. So that requires energy. And of course, if we have a weaker hold on the valence electrons, it will take less energy to remove it. So an electron is held more weakly if it's farther away from the nucleus, in a larger electron ring, and if there's more electrons on the inner rings shielding or blocking that positive charge from holding on to it. Ionization energy. So as we go down a group, it's easier to remove the electron for the reason I just explained. It's farther away and there's more shielding going on. So the energy needed will decrease as we go down a group. And so that's the explanation for 11. And across period, well, same thing. We have an increasing effective nuclear charge, which holds onto those valence electrons in the same electron ring as we go across a period, holds onto it more tightly, so it takes more energy to remove them as we go toward in the direction of the noble gases. Electronegativity. Now we're talking about the electrons within a bond. Diagram B is the best to represent electronegativity because we have a bond formed already. So unlike A and D, those are out. And it's the attraction of an electron in a bond to the nucleus of one of the atoms. So the arrow for B is indicating that definition. As we go down a group, electronegativity decreases, and that's again due to the electrons being farther away and the shielding of the inner electron rings. And across a period, again, it's the effective nuclear charge increasing, so there's going to be a stronger pull from the nucleus on electrons that happen to be in a bond with that atom of that element. Another multiple choice there, 17. We want to write the trends that we learned in the lesson under the periodic table that indicates that trend. So increasing as we go up and increasing as we go to the right would be those three trends here. And increasing as we go to the left and increasing as we go down would be atomic radius. So those are the way the trends work in those directions. And there we have it. Some summaries and explanations of the solutions for lesson 1.3 worksheet. Talk to you in the next one.